Okay, we're going to have a look at the discriminant. Remember that the discriminant is given by b squared minus 4ac. And some conditions for the discriminant are when it's greater than 0, that means that roots are real and distinct. Or you can phrase that as real and unequal. When the discriminant is equal to 0, that means that the roots are real and equal. And when the discriminant is less than 0, that means that the roots are non-real. It's important as well that we've got an idea of visually what that looks like. When the discriminant is greater than 0 and the roots are real and distinct, that'll look like that. So there's two distinct roots, so it might look like an inverted parabola, but it's still two distinct roots. Real and equal, that's one solution. And no roots are when there is no contact at all with the x-axis. Okay, first thing we're going to look at is making some calculations of the discriminant given a quadratic equation. So let's say we had 4x squared plus 3x plus 5 is equal to 0. And we're going to calculate the discriminant. Well, first of all, let's identify a, b and c. A is the coefficient of x squared, that's 4. B is the coefficient of x, that's 3. And c is everything else, and that's 5. So b squared minus 4ac. So that will be 3 squared minus 4 times 5. That's 9 minus, well, 4 times 4 is 16. 16 times 5 is 80. So 9 minus 80, and that is minus 71. Now, if the question had then asked us about the nature of the roots, we'd say that d equals minus 71. Minus 71 is less than 0. Therefore, roots are non-real. Okay, example 2. Calculate the discriminant and find the nature of the roots for 4x squared minus 12x plus 9 is equal to 0. Okay, so a is equal to 4, b is minus 12, and c is equal to 9. So b squared minus 4ac minus 12 squared minus 4 times 4 times 9. Minus 12 squared is 144. Then we've got 4 fours are 16, and 16 times 9 is 144. So d equals 0. Therefore, roots are real and distinct. Okay, let's try example 3. Find the discriminant and calculate the nature of the roots for 5x squared is equal to 4x plus 7. Okay, first of all, we need to make the thing equal to 0, so bring these over. That'll be 5x squared minus 4x minus 7 is equal to 0. A is equal to 5, b, be careful, is equal to minus 4, and c is equal to minus 7. b squared minus 4ac. So minus 4 squared minus 4 times 5 times minus 7. Minus 4 squared is 16. We'll then get minus 4 times 5 is minus 20. Minus 20 times minus 7 is going to be plus 140. So that's 156. So d equals 156. 156 is greater than 0. Therefore, roots are real and distinct. Okay, let's try another. So this time we're going to look at finding an unknown value, which is p. So find p given that 2x squared plus 4x plus p is equal to 0 has real and distinct roots. Okay, the first thing that we do there is communicate to the marker what the condition is for real and distinct roots, which is that the discriminant is greater than 0. I'm then going to identify a, b and c. So a is the coefficient of x squared, that's 2, b is the coefficient of x, that's 4, and c is everything else, that is p. So 4 squared minus 4 times 2 times p is greater than 0. I've now got 16 minus 8p is greater than 0. Now this question has now morphed from a discriminant quadratic question into a linear inequality. So we solve linear inequalities like linear equations, so letters to the left and numbers to the right. So that would be minus p is greater than minus 16. Now remember, for solving linear inequalities, that if you divide through by a negative number, you must flip the inequality at the point of division. So for solving linear inequalities, it's letters to the left, numbers to the right, just like equations. But if you're going to divide through by a negative number, you must flip the inequality at the point of division. Now I'm about to divide through by minus 8. So I'm going to flip the inequality at the point of division, which is right now. And then 2 negatives cancel out, 16 over 8 is 2, so p is less than 2. Okay, let's try another. For this quadratic equation, we're going to say that it's got equal roots. The quadratic equation is 3x squared plus 8x plus a is equal to 0. And the task is to find the value of a. So first of all, let's communicate what's going on. The discriminant will be equal to 0 since we've got equal roots. Let's identify a, b and c. So a is 3, b is 8, c is a. And let's put that into b squared minus 4ac. So that will be 8 squared minus 4 times 3 times a is equal to 0, since the discriminant is equal to 0 on top of that. So it's 64 minus 12a is equal to 0. So that will be minus 12a equals minus 64. A is equal to minus 64 over minus 12. Okay, so the negatives cancel out and I can divide top and bottom here by 4. And that will bring me down to 16 over 3. Okay, let's try another. We've got the quadratic equation kx squared equals minus 5x minus 10. We're told that the roots are equal. And the task is to find the value for k. So first of all, we must make the equation equal to 0. So that's kx squared plus 5x plus 10 is equal to 0. We can now identify a, b and c. A is k, b is 5 and c is 10. It's then b squared minus 4ac is equal to 0 since we've got equal roots. It's then 5 squared minus 4 times k times 10 is equal to 0. That's 25 minus 40k is equal to 0. That'll be minus 40k is equal to minus 25. And then k is equal to minus 25 over minus 40. The two negatives cancel out and I can divide top and bottom by 5. And that will give me 5 over 8. Okay, let's try another. This time we're going to say that we've got a quadratic equation which is x squared minus 4x minus a is equal to 0. We're going to say then that the discriminant is equal to 7 and find a. Okay, so a is equal to 1, b is equal to minus 4, and be careful, c is everything else, that's not a, that's minus a. Now we know that b squared minus 4ac, the discriminant, is equal to 7. So that's minus 4 all squared, minus 4 times a, which is 1, times minus a, which is c, and that will be equal to 7. That's 16. Let's be careful here. Minus 4 times 1 is minus 4. Minus 4 times minus a is plus 4a is equal to 7. 4a is equal to 7 minus 16, which is minus 9. And a will be equal to minus 9 over 4. Okay, we're going to just pause and think about our different conditions for discriminant again. So remember that greater than 0 roots are real and unequal, or real and distinct. Two solutions, b squared minus 4ac is equal to 0. Roots are real and equal. One solution, and b squared minus 4ac is less than 0. No solutions, roots are non-real. Okay, let's have a think about a scenario in which we were hedging our bets and we were saying that the discriminant was greater than or equal to 0. So greater than or equal to 0 means it may be greater than 0, it may be equal to 0, we don't know. Now we know that if the discriminant is greater than 0, then the roots are both real and unequal. We know that if the discriminant is equal to 0, the roots are real and equal. Now if we don't know whether it's greater than or equal to 0, we need to hedge our bets and say it's either that or that. Now all we can say with certainty there is not that the roots are unequal or equal, but only that they are definitely real, because that appears in both lists. So b squared minus 4ac is greater than 0, greater than or equal to 0 rather, means that the roots are real. Okay, let's try a couple of questions related to that. For what value of k does this equation have real roots? X squared minus 4x plus k is equal to 0. Okay, first of all, a is equal to 1. As we can see, b is equal to minus 4 and c is equal to k. Let's put down the condition for real roots. The condition for real roots is that the discriminant is greater than or equal to 0. Let's plug that in. So it's minus 4 all squared minus 4 times 1 times k is greater than or equal to 0. That's 16 minus 4k is greater than or equal to 0. We've got a linear inequality. So letters to the left, numbers to the right. So minus 4k is greater than or equal to minus 16. Again, what's going to come into play here is dividing through by a negative number. So remember, with a linear inequality, if I divide through by a negative number, I need to flip the inequality at the point of division, which is just now. And then minus 16 divided by minus 4 is 4. So the final answer then is k is less than or equal to 4. Okay, let's try another. For what value of k again does each equation have real roots? So this time the equation is 2x squared plus 20x is equal to minus k. First thing that I must do is make the equation equal to 0. That's part of my preparation. So that's bringing that minus k across and making it plus k. I've now got a is equal to 2, b is equal to 20, and c is equal to k. So for real roots, I know that the discriminant is greater than or equal to 0. So that's true for real roots. Okay, so 20 squared minus 4 times 2 times k is greater than or equal to 0. So that's 400 minus 8k is greater than or equal to 0. minus 8k is greater than or equal to minus 400. I need to flip the inequality around because I'm about to divide by a negative number. And the negatives cancel out. 400 over 8 is 50, so k is less than or equal to 50. Okay, let's try one more. For what value of k does this equation have real roots? And the equation this time is kx squared minus 2x plus 1 is equal to 0. Okay, so a is equal to k, b is equal to minus 2, c is equal to 1. Okay, let's put down the condition. B squared minus 4ac is greater than or equal to 0 because we've got real roots. So minus 2 all squared minus 4 times a, which is k, times c, which is 1, is greater than or equal to 0. That's 4 minus 4k is greater than or equal to 0. Minus 4k is greater than or equal to minus 4. Flip the inequality around because I'm about to divide by a negative number. And minus 4 divided by minus 4 is 1k is less than or equal to 1.